Good morning, friends. Today we are going to discuss something on global positioning system, which is called GPS. Let us understand what is GPS. GPS is nothing but a network of satellites that continuously transmit coded information, which makes it possible to precisely identify locations on Earth by measuring distance from the satellites. You will find the figure below talks about the global map, which has been shown in an expanded form, and normally we agree that these positions do not change, these physical positions, and this is the concept behind mapping this digitally as to how this can be kept in a physical format but represented logically or virtually. This is about GPS. In this figure you will find there are two figures. One, the left part talks about the axis, is a three-dimensional axis where the satellites are supposed to be located, and each position of the satellite is related to your globe, that is, which is nothing but a typical model that we create. You will find the globe which is available everywhere. You can put it in your house or on your desk. This talks about the global presentation, which is called the virtual presentation of the physical globe, which is miniaturized to make you understand how the physical space of the globe has been mapped. And the right side you will find there are 4 satellites which are actually going towards the mapping process. It is said that minimum number of 4 satellites should be there to cover a typical coordinate in a very effective manner. Why 4? Minimum 4? We said that maximum angle that a satellite can provide is of 90 degree, and in order to have 360 degree views, naturally you should have 4 satellites minimum. If you want to have more, you have to reduce the angles, and you see that number of satellites are actually more and more. What do you require in a satellite positioning, and what is a position? There are 2 issues which are actually involved here. One is called static positioning, the other one is your kinematic positioning. What does it mean? The satellite should be positioned in such a way that the geocenter of the Earth is mapped continuously and in a static manner. And you will find the satellite, which is the outer space of the globe, is in an orbit. What is an orbit? It is a logical space again around which the satellite moves at a pace which is just understood by the center, which is placed in one of the physical space in the globe, in the Earth. So we are supposed to see whether the satellite is having a referential speed of 0 or relative velocity of 0, then it becomes a position which is actually static in nature. But today satellites are also moving, and also it is trying to map the objects which are also moving today, like your trucks are moving, your ships are moving, your plane is moving, but how to actually position them? That means dynamically the coordinates are also moving. That is also possible, and that is called kinematic satellite positioning. Here in this figure you will find the geocenter is mapped. Geocenter is related to the Earth's geocenter. Satellite position is also mapped in the orbit. Now naturally you find there is a light that satellite is going to place on the geocenter, and that distance is known. Distance, because that is the speed of light which we talk about. And then that once that distance is known and we have an object, we have the observed value of delta t, which is on the upper side of the triangle. So if I am going to determine the space, the distance between the geocenter and the object, naturally satellite has to have 2 references. One is the known reference based on the geocenter, and another dynamic delta t, which may be related to the placement of the object we are going to measure. This is how the satellite is positioned, and it measures the distance. How it works, let us understand. It talks about trilateration ranging system. This talks of saying that mostly a satellite moves at 4 km per second. So what we are supposed to do? There has to be a GPS receiver which detects the range signals in either one way or multiple ways. Time of arrival should be compared with the time of transmission, because satellite has to transmit the signal, it has to go back to the satellite, then you will compare through a computer, which is again analyzed in the base station, we will see later, and then this delta t, which is depending on the movement of the object or the static nature of the object, we always measure the distance. That means the range will be there in the satellite, which is always measured through some type of references. And let us see how it works. See, you know, a receiver is going to send signals to the satellite, satellite also sends a signal back, and the range is the time taken by the receiver to send the signal and satellite to respond, and then the speed of light is the multiplier. This is how the range is measured. As I told you earlier, there are 4 satellites trying to map the object. Why there are 4? I already told you that this is going to map the entire globe depending on the angle that it has. And then why GPS? It is very interesting to understand that traditional signals are always influenced by weather, ionosphere, and a line of sight also is at times required. It cannot be on broadcast mode. So there are various issues actually involved when we discussed about GPS. When you compare with GPS with other traditional methods, you will find, like your microwave and all, you will find lot of improvements are there in GPS. They give a high geodetic accuracy. This can be operated in day and night. It is quicker, talks about less manpower, talks about, because of the cost advantage, it is economical. Today we are having GPS systems everywhere, and it also works on common coordinate system, and it also has a wide range of applications, including your applications in agriculture, like your precision farming. And today there are various private satellites which are also being sent to the orbit, and they are also working on that. Because of this, competitiveness also has come up. What are the basic components of your global positioning system? There are 3 basic components. One is the satellite itself. We are going to base those satellites in one orbit. Orbit is actually monitored globally at a Navstar, and this is going to say that how many satellites can be placed in an orbit. I said that in an orbit there will be 4 minimum satellites, and it can grow depending on your price, it will be depending on your business values, and depending on your intensity or sensitivity. All these will require number of satellites to be placed in the orbit, but minimum in an orbit will be 4. And the second one is your control segment, which is just right side of the figure. It says that there is a one master station for all the orbit based satellite controls. That is going to receive all the data, is trying to monitor the functioning of satellites, and also is trying to update the information that are supposed to be there in the satellite. And then there are 5 monitoring stations for each orbit. So it says that this control segment is going to be housed in such a way that it all controls all the satellites placed in the orbit. The third one, with the left side of your figure, talks about the user segment. User also should have that capability to receive the signal, send the signal, get the information out of the analysis done by control segments and the analytical features available in the satellite. You will find ordinarily 24 satellites can be provided to cover the earth very professionally, and it says that 4 satellites in 6 orbital planes can be provided. It can be placed in a typical orbit of 20,200 kilometers. This is one orbit which is showing up. It can have 12-hourly orbits that can change the positions, and it can be in view for 4 to 5 hours, and every satellite can have a life of around 7.5 years. It means the business value has to be understood properly before you are going to place a satellite, and also the service that is supposed to provide to us, because less lifetime. Within that period we are expected to locate your satellite and get the benefits. and this is going to create a lot of challenge. After the life is out, what are you going to do with the satellite? This is a major challenge still with us. And let us see what are the control segments that we are going to have. In a master control station, we are going to track data from monitoring stations and calculating satellite orbits and clock parameters. If we do not do this, we will not be able to control those satellite movements. And what about monitoring stations? It talks about pseudo range data measurements. What is it? The satellites may also get some type of transmit certain type of data by on its own, and this is going to provide a lot of challenge for the monitoring stations to track them for each orbit and for each satellite, and look at their broadcasting patterns, and also synchronize the clocks across all those satellites along with the ground stations. It also is responsible for uploading information to the satellite. And the third one is your user segment. It needs to have a GPS enabled data receiver. Mostly you will find we say my mobile also is GPS enabled today, my mobile also is GPRS enabled today. That means we are getting into kinetematic environment, but mostly you will find all the applications which are for agriculture and all can be static monitored. So we are supposed to have a data receiver, there has to be GPS data processor, and we should have applications in the user device. What a user device should have? It should have an antenna, should have a power supply, a command unit with radio frequency section, microprocessor, recording device, all these are supposed to be part of your GPS receiver. And now we are having handheld devices also, and today because of this handheld device GPS receivers, we are able to track the vehicle that we are driving today, and that is dynamic in nature. That means each vehicle has its own coordinate which is moving around, and the satellite is able to track it dynamically. So this is a very good thing that has happened for us. We are able to track them and see that the objects are clearly mapped. Interestingly, you will find this service has come out of the defense systems, and today the civilians are going to get this service which is of defense quality. That means sensitivity, accuracy, all these are supposed to be there, and we are taking advantage of this defense R&D interventions and innovations. And ideally, if you are going to place those 4 satellites for mapping the entire globe, this is the figure which talks about one is your geocenter, and one in south, one in the east, and one is in northwest. And this is the best possible combination that has been achieved and showcased. And what are the bad or poor satellite geometry? You will find this is one of the examples which is skewed towards one portion. Another figure you can say that talks about the interference. Despite having all those limitations, advantages, signals of these satellites can also be interfered with, like one in the ionosphere, second one there is ionosphere in the top, and then by reflections and electromagnetic interferences like your electrical lines. Even your high rise buildings, they can also provide some type of reflective signals as well as refractive signals, and we have to be very, very careful. That is why ground stations are actually working harder with technology innovations to filter out those unwanted signals coming out of reflections and refractions. So we should be very, very careful and see those limiting factors when you are going to place your satellites. GPS can be used for surveying techniques. As I told you, you can be static in nature and you can also be moving in nature. Today this is very rigorously being used for MG-NREGS work. Today volunteers are able to map and measure the road length, send the signals to understand the quality of the work, look at the pond renovations, their depth, their volume, everything is also being done through GPS techniques. In the figure on the right hand side you will find the person is going to survey the road, and this stop and go things are very good for the surveyor, because if you are going to map, let us say, agriculture field, you can always go to small coordinates that is feasible for you, and then continue to do mapping of the entire agricultural field. And it also talks about the quality of the saplings, and then the quality of crop. This can also be measured there. And in your moving pattern, as I told you earlier, there this car is moving, we are able to track the entire coordinate and see that the trajectory is provided. When you are in a flight, you can also look at the trajectory map that is being prepared by the satellite instantly and on a real time basis. Today GPS has come up to the stage of real time monitoring and tracking, and that is very good for not only for defense but also for civil services, and also lot of things are happening because of this dynamic planning. We are able to use those GPS techniques for precision farming as well, and we are able to measure those services in your various fields and transmit signals to the remote centers, which are analyzed, and then proper advice is given to the farmers. Today we have discussed about geographic positioning system. This is totally totally aiming at various services, not only limited to defense but also for other services including farming systems. And if you want to get more details on this, please visit the documents you have with you, and also visit the website of MANAGE to get more information on that. Thank you very much.